Hi everyone, welcome to Byte and Beyond with Uday. In this video, we will learn why database relationship exist because we all know there are relationships in the database such as one to one to many, and many to many. But the question is why? Why do we need this type of relationships in the database? So that's what we are going to clarify today. Okay. And we will also understand this normalization concept, which is related with the database relationships. And in the end, we will have a clarity. So this is the agenda. So let's begin. So if you can see this table over here, we have four columns: employee ID, employer name. It is basically employee name, department name, and department location, right? Four columns. But if you focus on these two columns, department name and location, you should see multiple duplicate entries of the data. For example, let's take a sales department. Alice belongs to sales, so we have entered sales over here. Bob also works for sales department, so here again we can see sales. Okay, and sales department belongs to the New York location. So that's why we can see, this duplicate location entries as well as duplicate department names. So this is not a good design. This is a bad design for the table. We should not design table in this way. This is the example of bad design, right? So what can we do about it? And this kind of table has multiple problems. Okay, the data duplicacy is one of the problem. You can see multiple duplicate entries over here across the department. You can take sales, marketing, HR, IT. Same goes for the location. Multiple duplicate entries for the locations as well. New York, Los Angeles, Chicago, right? So data duplicacy is one of the problem. Apart from this, we have few problem as well. So let's talk about it. So if you see, let's say I want to change this New York location to Boston. So if I need to do that, I need to update multiple rows. Why? Because as explained, we have multiple entries for the New York. Okay. You can see over here, and over here. I need to make a update on multiple rows. In this case, four additional rows. This one, and this one. So this is not right because I should be able to, update the data at a single place only. So due to data duplicacy, I need to update these New York location to Boston at fourth different places, which is not correct. Now let's take an example of delete as well. Now let's say I want to delete Chicago location. Okay. Now as you can see in this table, okay, I have Chicago location at two rows. So I need to delete these two rows cells, which is not correct. For the delete and update, I need to perform multiple times update and delete operation. For delete, I need to delete this column cell and this one. Okay, and same for the update. I need to update multiple column cell. This one, and this one as well, which is not right. Okay, so these are the problems we will end up if we design our table in proper way. Okay, so these are the few problems. So now we have talked about the problems. But what is the solution? How can we avoid such problems? How can we improve our table designs? That's where come normalization. So, so what is normalization? Let's read this simple definition, then I will explain. Normalization is a way of organizing data to remove duplication and maintain consistency. Okay, this is the simple definition. Remove duplication and maintain consistency. This is great. Okay, so you can see same table. This is the problematic table. Now, in order to design better table, how can we fix this problem? Okay, now we have a problem. How can we fix it? So through the normalization concept, we can create multiple tables instead of having one large table who has lots of columns, and due to those columns we have duplicate of data. Let's divide this table, right? So over here I'm going to create few tables out of this. Okay, out of this bad table design I'm going to create few tables, okay, to avoid duplication and to maintain consistency. So you can see I have created three tables over here. First one is employee, which only contains employee related information. Then I have department table, which contains only department related information. You can see sales, HR, IT. Then I have a location table, which contains only location related information such as New York, Los Angeles, Chicago, Boston. Okay, this kind of type of data will contain by the location table. But now we have created a table, multiple tables. Now how can we connect? Okay, that is also the another concern. Now we have, you know, do some partition, or we have divided a huge big table into the smaller tables. But how can we connect it? How can we connect this table with each other? Okay, that is the question that we will look into in some time. So hang on it and keep this mind in your question. Keep this question in your mind. We will talk about it. But before we do that, l- normalization has few rules. Okay, so let's talk about it. So these rules will help us to design our table in a better way. Okay, so you don't need to memorize these rules, just understand what exactly it says. So that is our agenda. Don't memorize, just understand the concept, what exactly it tries to say or explain. So let's check out the first rule. First rule is first normal form. So it says each column should contain atomic values or single values. So this is the example of bad design. Okay, same table. Okay, same that dirty table which we have seen earlier. But the problem over here we are highlighting is, if you see this department column over here, we can see two department name with separated by comma, HR and finance, which is wrong. If we do this, we are breaking the first normal form. Each which says each column should contain atomic meaning single values. So this is the correct design, right? If Alice belongs to two department, then we should have two rows. First one for HR, second one is for the finance. We should not store data like this: HR, comma, finance. Each column cell should save or should contain only single value. So this is the correct design. First cell contain HR, second cell contain finance. Now let's move to the second rule. So this is the second normal form, which says no partial dependency on the primary key. Okay. So if you see this table, the dirty table, so what the second normal form says, no partial dependency on the primary key. So if you see this employee name column, this depends on the employee ID. So which is correct? Employee ID is the primary key and employee name depends on the depends on this employee ID primary key, which is correct. But in case of department and department location, this these two columns does not depend directly on the employee ID. So over here we are breaking the second normal form, which says no partial dependency on the primary key, because employee name depends on the employee ID, that is correct, but department and department location does not. So this is the example of partial dependency. If all the columns depends on this employee ID column, then that is great. But over here, we are not following that rule. So in order to fix this problem, what can we do? We can create two tables, employee table and department table. You can see employee ID, employee name and department ID. Now if we see employee ID, this is the primary key, and employee name and department ID. Okay, these are the other columns. Okay, but this both columns depends on the employee ID. Why? Because if we want to know what is the Alice primary key, it is 101. What is the Alice department? Okay, the employee's ID, Alice employee ID is a 101. Now I want to know the employee ID who has 101. It belongs to the which department? So for that I can use this ID, that Alice belongs to the sales department, and sales department location is New York. So that's how we can map. We have two tables, okay, employee and department, and this column is added for the reason because we want to connect these two separate tables, department and employee. And I am saying Alice belongs to sales, Bob belongs to one, meaning over here, this department ID, sales. Same for the Carol. Carol belongs to HR. Dave also belongs to HR. Eve belongs to IT department. So that's how we can map. So this rules is also clear. Let's move to the next rule. This is the third normal form. So it says no indirect transitive dependency, right? So there should not be indirect transitive dependency available, right? So if we see this department location depends on the department, right? Because it these locations are not standalone, because there is no value of this location standalone, because we need this location to indicate that this particular sales location belongs to New York, right? And this sales department, this department column ultimately depends on the employee ID. So for the department location, there is a chain: department location, department, and then employee ID, which is wrong over here. So there is a chain of transitive dependency. If you see employee ID, employee ID has a connection with department, and department has a connection with department location. And this everything is belongs to the single table. So which is wrong. So to avoid this, we can do the similar we can use the similar solution which we have used in the second normal form. So over here as well, we are going to create two separate tables, employee table and department table. And we are going to connect these two different tables with the department ID. Okay. So these are the rules. First NF, two NF, and third NF. Okay. This is the short form basically. And this is the normalization. So normalization basically teach us or motivate us to design a table a better way while keeping these three rules in our mind. So whenever you design your table, you should always keep this normalization concept in your mind. So that's why we need this kind of relationship. Okay, one to one, one to many, many to many. That's why this relationship exists. To manage our data in a better way, to design our data or to design our table in a better way. Instead of, adding everything in a single table, let's design our table in a better way. So that's why we need these relationships. You can talk about one to one to many to many. That's why these relationships exist. So we can design our data in a better way. We can design the table in a better way to avoid the duplication and maintain the consistency. So let's pick a same problem again. And now we will talk about these relationships one to many, and many to many. So let's pick a same problem which we have seen. We have same dirty table which contains employee information as well as department information. Let's let me move to the next slide. And how can I, using the normalization, how can I design these tables in a better way? So let me go to the next slide. So over here, you can see this is the design which I am going to implement. This is the dirty table, this is the employee table, and this is the department table. And as you can see, I have divided these two tables. This contains employee ID, employee name, and department ID. This is to connect. This department ID belongs to employee because I am going to connect these two tables, right? So this is basically many to one relationships, many employees, one department, right? So let me go to the next slide. You can see we have one department and many employees, right? So if we design this, we can create this kind of tables: employee ID, employee name, and department ID. This is the department table. So you can see we don't need to duplicate these records now. We are not repeating department name again and again. Instead of that, we are using department primary key as a foreign key in this employee table. So this is the example of one to many relationships. Over here we have one department, many employees. We can say other way as well. Many to one relationship, many employees, one department, right? And you might thinking why we need to add this department ID column in employee table. Why? Because as we know, we have multiple employees who belongs to the single department. For example, we have two employees, Alice and Bob. These two employees belongs to sales department. Now let's assume we are not adding this department ID in the employee table. Instead of that, we are going to add employee ID in this table. But we will, in this case, we will ending up in the same problem. Which problem? The data duplication problem. Because now I have two employees, Alice and Bob, right? Now if I need to add this employee ID column over here, then I need to make two entries of this row, this first row, sales. Okay, for the sales department, I need to make two entries. First for the 101 Alice, second for the 102 Bob. So that's why it makes sense that this department ID hold this employee table hold this department ID column, right? Because you should always keep in mind what whenever the many tables, who has the many, those contain the ones those contain the w- ones table primary key as a foreign key. For example, let me simplify this. So as we know, we have many employees, and those belongs to the single department. So this is many, this is one. So you should always remember the many table contains the additional column which is department ID, right? The one column never contains the additional column. To connect these two tables, always remember who has the many word. Okay, over here we have employee has a many word because many employees, right? So that's why many contains the department ID. If we add, as I explained, if we add employee ID over here, again we will need to create duplicate entries of the rows, and we will ending up in the duplicate data situation. So that's what we need to avoid. That's what we don't need, right? So that is why we are adding this department ID column in the employee table, and we can connect these two table with each other, and we can map this employee to the department ID. And by going through this table, I can clearly say that Carol belongs to this HR department because it contains ID 2, and Dave is also belongs to HR department. Then we have Eve. Eve also belongs to, yeah, Eve belongs to the IT department. So that's how we can connect. And that's why, as per my explanation, this employee table contains the department ID and not the other way, right? So one to many clear or many to one clear, you can say either way. One to many. When you say one to many, one department, many employees. When you say many to one, many employees, one department, right? Okay. Let's move to the next slide. So this is one to one relationship. So this is employee table, and we have employee profile. Because why one to one? Because each employee has its own profile, and there is a rule that, let's say, let's pick an example of Facebook or Instagram, right? So we all have those kind of social media accounts, and we all have the profile. So as you know that my profile belongs to me only. So another person cannot have my profile, right? For example, let's take a Harry. Harry has its own profile. So there is only one to one connection. If there is, let's say, Harry and Emma, both have a same profile, in that case we can say there is a one to many relationship, right? But this is not the case. That is wrong, because over here our situation is one employee can have one profile, similar to Facebook and Instagram. One user can have one profile, right? Profile. So that is why there is a one to one relationship. And you can see, if I talk about columns, then this contains employee ID. Employee ID is a primary key. Then this is a name. Okay, this is the employee name. Now, as this is a one to one relationship, I can directly use this primary key as a foreign key inside the employee profile. For example, let's say we have Harry. Harry has a ID 1. The same ID will be added over here, and in the position column we will add the required data. Same for the Emma. Let's say Emma has a second ID. Same ID will be entered over here in the employee profile table as well. These two tables are separate, employee table and employee profile table. But the primary key is shared with these two tables. This is the primary key, and this primary key is shared with the employee profile table. And as this is the primary key of employee ID, hence it is become foreign key for the employee profile. So this employee ID shared with the employee profile table. So if the employee ID Harry has one, the profile ID will be one. right? Because it is shared. So this is one to one relationships. Now, mm, if I talk about many to many relationships, so for example, let's say we have two tables, student and course. As we know that one student can have multiple courses. For example, language, science, mathematics. So let's say Harry, okay? Let's say student A. Student A has a multiple courses, right? Such as language, mathematics, and science. Similar for the student B as well. Student B has slightly different courses, but it also contains multiple courses such as drawing, science, and mathematics. Same for the courses as well. If you see from the course side, the mathematics course is taken by the both students, student A and student B. So from the course perspective as well, mm, more than one students having mathematics course, more than one students having that science course, right? In our case, A and B both having the science and mathematics course. So this is the many to many relationships, and in many to many, we cannot have a column in each other's tables, because if we do that, we will ending up in the duplicate data. So instead of that, what we can do, we can have her table, which is student underscore course. What it will save? It will save student ID and course ID. For example, let me give you example. Let's say we have student A, it has ID 1. Okay. Now let's say we have multiple courses. Let's say mathematics and science. Mathematics has ID 1 and science has ID 2. Now, as we know, the student A belongs to student A interested in two courses, the science and mathematics, right? So over here the ID will be 1, and then over here the course ID will be. So over here we will have two columns, the student ID and course ID. Okay. So over here the student A ID is 1, and over here mathematics ID is 1. Then again there will be another row. Okay. Student ID 1, course ID for science it is 2, so it is 2. Same for the student B. Student B's ID is 2, so there will be 2. And course ID, it is also, and student B is also interested in mathematics, so course ID will be 1. So the mapping will be 2 1 and 2 2. 2 1 meaning student B mathematics. 2 2 meaning student B science. Right? So that's how we can have, or we can design this kind of relationships. That is why this is the reason these relationships exist. Okay, to make sure that our data is consistent and we avoid data duplication. So that's why these relationships exist. So now you should have clear understanding why database relationship exist, and that is why we have this kind of relationships, one to one to many to many, because we want to maintain data integrity, efficiency, flexibility, right? So this is the actual reason behind this, and this is the main purpose of having this kind of database relationships. I hope this concept is now clear to you. If you like my video, then please like, share, subscribe, comment. See you in the next video. Bye.